that's the best setup yet, but we'll see. Like some of the other ones, the board is kind of lean. It bothers some people. So, yeah, so announcements before we begin. WebWork is finally up and running, so you should be able to log in now. Make sure you check all the instructions on the syllabus. Make sure you can actually log in. The login, the username and password are the same. It's just the first part of your email. If you have any trouble with that, you can let me know. And YouTube videos are also finally up. The channel is set up, so you should start be able to see those. And if there are any suggestions on the view, if you think I could actually pan out wider, or this is the right size where you can see properly, that should be good. Rough schedule. So again, quizzes every week, so you can expect one roughly every Tuesday, unless you have a test on that week. And I'll usually post the answers around Friday, because I'm teaching several sections of this course, and I might want to put similar problems on quizzes for other people. So I'll delay posting the answers for a few days. I will typically return the quizzes. I'll try to return them that Thursday, if not the following Tuesday. I'll give you the quizzes back. So those are just some announcements before we begin. And now we're going to go through these problems.
I have a question.
Yes?
Don't you do the quizzes on Wednesday during recitation?
Oh, yes, Wednesday, sorry. Yeah, see, teaching so many sections. One of my other sections do it Tuesday. You do it Wednesday. Yes, thank you. Yeah, so we're going to go through these problems, and I think that's all I want us to go through today. I had a completely different lesson plan for today. I put these problems on the board in my morning class, and I figured, okay, yeah, we'll just knock out these, the first 10 minutes of class, we'll be getting to problems, and I can go into what I wanted to do. Turns out that it gave students a little bit more trouble than anticipated, but I'm actually glad how it turned out, because we learned a lot of valuable lessons by going through this problem about how to look at things in this situation as well as math in general. So, yeah, I think it was a very productive class. I'm not sure if the students appreciated how productive it is, but I figured I'm going to do the same thing with you guys. So, let us start with problem 1A. Okay, someone tell me how to do this. What do you think the answer is here? Yeah?
1/2.
1/2? Did anyone not get 1/2? Did anyone not do anything? Yeah?
I got 2.
You got 2?
Yeah.
Okay, so some people got 1/2, you got 2. Any other answers out there? Okay, so explain to me, how did you get your answers? What did you do? Okay, so you have this guy. What do you do? Suggestions, tell me what to do. Right out there. Yeah, what did you do?
You could raise 2 to the power of -1, like with the because it's negative from the natural log. So natural log is 2 to the -1.
Okay.
Right, that'd be so that's 1/2.
Why can you do that?
It's one of the rules for logarithms. You can move the coefficient from a log to make it the exponent.
Right, so this is because there's a rule that says if we have something, log of something to a power, you can bring the power down and move it up at will, okay? And then what?
It cancels. The natural log and the rules cancel.
And what did you get here?
2 to the -1 or 1/2.
Alright, that says 2 to the -1, and where did that come from?
The negative exponent is the same as the reciprocal. Or the,
Well, you're talking about here. Well, yes, if you get the 2 to the -1, you can jump to 1/2. But how do you go from this to that side?
it's because the natural log is base e,
Okay.
so it just will cancel out.
Because what?
reciprocals of each other?
They're reciprocals of each other. That's not exactly the right word. They're inverse functions, but more or less what I want you guys to think about is there's this rule. Now, I believe someone got 2. How did you get 2? What did you try?
I thought those just canceled out. I forgot the negative.
Yeah, but if so, then what did you do with the negative after?
Yeah, I just got rid of it. I was like, just canceled it, just wrote 2.
And just it's just like just
Yeah.
I don't like that negative. Let me just ignore it. There are other ways you could have done this problem. Can anyone see another way? Maybe a slightly different way? Yeah?
I put 1 over e to the ln.
Right, laws of exponents. We know we have a negative power. We know that's just 1 over that. Okay, and then
The e and the ln.
and now you can apply this rule right here. And so that would just give you the 2. So you get a half again. Any other way to look at it? Did anyone do it differently? I know different students will see different things. I just want to make sure you're all seeing valid things. Yeah.
I wrote e to the power of negative ln 2 equals 2 to the power of negative 1 because you can replace e to the power of ln with 2. Does that work, or is it just skipping steps?
Okay, so you kind of skip a step, but
Yeah.
based on what you described, this is what you did. You sort of thought of this as e to the ln 2, but you brought the negative 1 out here, right? Which is also a law of exponents. So yes, you went through to the ln 2 and to get the e beside each other, but you realized that you couldn't forget the negative 1. So inside the parentheses, that became 2. Yeah, so the moral of that story was you can't ignore the negatives. And I realized that a bunch of students in my other class actually did that. They're like, oh, you can just cancel these. And some people were getting -2, some people were getting 2, all sorts of things. And I really wanted to emphasize that the rules that I gave you last time, it's very important, and this will be in general. Any of the rules that I give you, it's very important that you follow them exactly as written. The rules are kind of your templates. Now you'll notice in this rule, for example, the rule that you would apply, where do you apply it? Well, in any of these, right? You'll notice that you can't just immediately go through and cancel things because there's a negative sign in front of this thing here. And if you look in your rule, there's nothing in front of the log there. See what I'm saying? So you cannot apply the rule directly to this as written because it doesn't match up. If I try to take this and fit on top of that, something would be out of place. See what I'm saying? So that's a very common mistake, and this is something I'll talk about later when we get to derivatives. I remember last class when I wrote down the difference quotient and I asked you guys, what was that? And someone said the derivative, and the thing is, it's not a derivative without the limit in front of it, and it's very important that you pay attention to little things like that. The devil is in the details, and you'll get into a lot of trouble in general if you're not following the rules exactly as written. And you kind of want to think of things as templates, right? So this rule tells you what your legal moves are. The trick is do not do anything unless you can think of a rule to back up doing that step. Okay. Let's move on. Okay, so there are a bunch of different ways to skin a cat, but there are only a few valid ways you can skin the cat. The correct answer for this problem is a half. You can get to that a bunch of different ways, but if you got anything other than a half, you did something wrong, and you need to really start paying attention to the rules. Let's look at B. B to the ln of 2. What's that? Yeah.
I got 3.
Okay, how?
So the ln and the e cancel out, so you get a 3. No, from the, in the bracket, yeah.
Okay.
So the ln and the e cancel out, and then
Right.
you get a 3. And then after that, the e and the ln cancel out, and you get a
Right, and that happened because, again, you're applying the rule that we know that log to the base a of a to some power is just the power, right? ln, you have to remember, it means there's a base e there. And so this and that, they're the same base. And so you cancel that, you get the 3, and again, you apply that rule again, so that will cancel and you got 3. Okay. Right. What was the other problem? Expanding the log. Okay, how do we do that? Huh? What? Anyone do that one? Good job.
First you can change the square root to the exponent of half. Then you can move the exponent outside. Then you can write equals half ln because you can move it outside.
Because we have a rule, if you log something to a power, you can take the power, you can bring it down in front. Don't necessarily have a rule with a radical in it, but you just have to remember, oh, radicals you can write as powers. You can do that. So then you would have this.
Then because there's division, we can write subtraction there. So
Right, we have a rule, the log of a division is a subtraction of the logs. Yeah?
So change the 1/2, like
Yeah.
minus 1/2.
Yeah.
Alright, you guys are on top of things. I was gonna ask, is that correct? And if anyone said yes, I was gonna throw my chalk at them, but now you guys. You need parentheses here, or you need to realize that the half needs to be distributed. Right? That goes back to not forgetting your parentheses. Okay, what else do we do?
You can change the product to addition.
Right, we have log of a product here. There's a rule that says that splits up. Okay, so we'll have that splits into an addition, right?
It will be negative
Why would it be negative?
because we are distributing negative.
Yes, again, you need parentheses here. And that negative sign in front would distribute. Distributed negative sign. All these little things can cause you a lot of trouble if you're not paying attention. Okay, now what?
You can move the exponent in front of the ln.
So here we have 1/2 ln x minus 1 minus ln x minus 3 ln x plus 1. Which, finally, I guess we could. I mean, that's probably okay, but. That would be your answer as a sum of logs. Knowing how to do manipulations like that are going to be important because you're going to realize the rules that we have for calculus. Dealing with the function in this form is going to be very complicated. Dealing with the function in this form is going to be very easy in terms of the calculus way. So you need to know how to do the algebra to get to nicer forms. But ultimately, that's what the answer should look like. Hopefully you guys are getting that. And the other problems. So we want to solve for x here. Let's see if x equals 12 first. I get rid of this?
Yeah.
Okay, what is x?
Just change the form to logarithm, so it will be ln 12 equals x.
How can you do that?
Because e power x equals 12 will be log base log e 12 equals x, and that's ln 12 equals x.
Okay. So the rule you're thinking of here is the rule that says you have log to the base a of b equals c. This is equivalent to saying a raised to the c equals b, right? So you have this form and you can jump back to that form. This double arrow here means you can go from one to the other. You can go back and forth, whichever is convenient. So here, you'll notice that this fits very nicely on top of that, right? The e is like the a, the x is like the c, the 12 is like the b. You can, if you want to isolate the x, which is in this case like isolating the c, which is what this formula does, that's going to be the way to isolate the c. So you can just change this to log to the base e of the b, which is the 12, and log to the base e is ln. So you can literally jump right to this over here. So your x would be log of 12, natural log of 12. There's another way, let me write another way of doing this. Or maybe I should ask you guys, can you think of another way of doing this? Yeah?
Well, you know, ln of e gives you whatever is raised to the e, so you can
Yeah.
get ln both sides, and then you get x is equal to ln 12.
Yeah, another thing that's valid, because it's an equation, you can do the same thing to both sides. And so one option is to plug both sides into an ln. So you ln both sides, right? That's kind of the phrase you would use. Ln both. So it's, let me put ln again in quotes. Technically you can't have ln by itself. It doesn't make any mathematical sense. You always have to have ln of something. Okay. So you can ln both sides. If these two are equal, then they should give me the same value when I plug into the log, right? And now we can apply the rule that says if the base of the log is same as the base of this guy, they cancel each other. And so that would give you x. And so that would give you ln of 12. Questions on that? What if ln x is equal to 7? What is x? Yeah.
That would be, like, the answer would be e to the power 7.
Right. You can get e to the 7 equals x by, again, that rule, log to the base a of b equals c, if and only if a raised to the c equals b. So again, this side would fit to the left side, and then you can jump here to isolate the variable. You can just do that. Or, in a similar fashion, if you have ln x equals 7, you can plug both sides into the power of an exponential. And colloquially, you might hear this referred to as e both sides. So if I say that, I don't want you to be confused on what I'm saying. So I can say, oh, you e both sides, or you ln both sides, blah, blah, blah. I mean, this is what I'm doing. And so now, another rule applies here. This will cancel, and then you would end up with x equals e to the 7. A couple valid ways to do that, not so bad. Questions? C. E. How do we solve it? Yeah?
It's 5 minus ln 4 over 3 equals x.
How? Give me the steps here.
So, like there you would ln both sides.
Okay, that's an option. Sometimes I'll be lazy and I'll just write ln on top of this. So that goes away. So we have 5 minus 3x equals ln of 4.
And then from there, it's just basic algebra.
Mm-hmm.
So subtract 5 from both sides.
Notice that the 4 is inside the ln, not the minus 5. Yeah.
Yeah, and then divide that both sides by -3.
Can you write that without a negative sign in the denominator?
Yeah.
How?
So then it would be like 5 minus ln 4 over 3.
Yes. This is good. We're moving a little faster than the other class. I'm not sure if it's because you're all better students on average, or maybe it's because it was the morning and they couldn't think very straight. Because who does math in the morning, right? Or maybe it's just a sheer numbers thing, because that class is much smaller. Here, there's a lot more opportunity for someone in this huge room to know what's going on. Only time will tell. We'll see if I can hear some more unfamiliar voices. Yeah, this one. Solve for x. How? Yeah.
You bring the ln x to the other side. You have ln 2x plus 1 plus ln x, and then you
Okay.
use the multiplication thing. It's ln x times 2x plus 1 equals 2.
Right. So you have that principle where you want to solve for a variable, you kind of want to try to isolate it, bring all the guys with x's to one side. Here you can apply a log rule. The sum of logs can be contracted. Now what?
You distribute the x across the 2x plus 1.
Sure. And you get 2x squared plus x. Okay.
Then you write e squared. Oh wait, yeah, e squared equals 2x squared plus x.
Right. E both sides.
Yeah.
Right? So you get 2x squared plus x equals e squared. How do you solve for x? It's a quadratic. Not very many people saw it in the last class. They saw this e squared here and it started freaking them out. Oh my god, what do we do with that e squared? E squared is just a number, it's a constant. Could have been a 3, could have been a 2, could have been whatever. It's a quadratic. There's an x squared, an x, and something without an x in it. That is the standard form of quadratic, so you treat it like any other quadratic. How would you do with a quadratic like that? Someone else. Take it from here. Yeah?
Subtract e to the other side.
Right, you move that to that side. You would not do something like factor out the nix over here, which is a common suggestion. You bring everything to one side, right? And what would you do here?
You can just use the quadratic formula.
Right. First thing you look for is you check if it could be factored. So you try to find a number that when you multiply it, you get minus e squared. When you add them, you get 1. You're not going to find such a number. So you just jump right into the quadratic formula. So your x would be minus b, which is 1 in this case, plus or minus the square root of b squared minus 4 times a times c. The c is minus e squared in this case, all over 2a.
Sorry, you meant 1 minus 4 times 2, right? Because you said e squared. I got confused.
Huh? 1 minus 4, yes.
Yeah, okay.
I said the e squared is like the c in the
Oh,
quadratic
okay. I
formula.
thought you said e squared minus 4, and I was like,
No. So it's 1 minus It's b squared, which is 1 squared, minus 4 times a times c, all over 2a. And you can make that look a little nicer, but not much. Let's just stop there. So the other lesson here is that you really want to memorize or be very familiar with the forms that you will have. There's a lot of times where things will look a lot scarier than they actually are, right? And even worse than this case. But you really need to understand what is a quadratic, for example. And so the fact that something kind of weird shows up should not cause you to freak out and do something. I think someone in the other class, they freaked out at this and they decided to ln both sides to get rid of that square. And I'm like, why are you doing that? You're kind of going backwards. Like, what do I do with these squares? Like nothing, it's a number. It's a quadratic. Just go with the quadratic formula. Okay. So that's something that will happen every now and then. Every now and then things will kind of look sketchy and so you'll just freak out and try to do something to make it look nicer. Sometimes you need to not worry, right? Know when things are constants, know when things are variable, and you're always trying to fit it on top of some form that's very familiar with what you're dealing with, right? So it's in cases like these where you have to be really familiar with algebra so much that you can see its forms in things that look really ugly on the surface, right? You're going to see a lot of things that look really ugly in this class, but they really boil down to something very simple in algebra. And unless you're really good at algebra, you're not going to see it all the time. Yes, so that is x. What is the other one? Can I get someone new to help me out with this one?
Okay, sorry.
You already answered a question. Is there anyone who didn't answer a question? Want to take a crack at this one? Oh, there is something I wanted to mention with the last one. But yes, I have to do some with the last one. Remind me. Okay, tell me what you did.
Since it's addition, you can multiply x and x minus 3.
So I can just multiply x and x minus 3?
Like, you have to log the whole thing,
Mm-hmm.
and then you have to, yeah, and then equal to 1, and then you could do 10 equals x squared minus 3x,
Where'd you get that from?
because the log has a base of 10.
Alright, so remember in our notation, if I don't write a base and it's not an ln, you assume there's a little 10 here. Okay? So you can raise both sides in the 10th power, or you can just directly apply rule 1, but at the end of the day you get 10 to the 1 power equal this. Now what?
You could distribute the x and then subtract 10.
Now what?
And then factor it and get x plus 2 and x minus 5.
Yes, that guy factors. Two numbers that multiply give you minus 10. When you add them, you get minus 3 is minus 5 and plus 2. And then?
And then x would equal minus 2 and x would equal 5.
By the way, to apply something like this, you need a 0 on the right side. Do not come into the mistake of trying here. Every now and then I'll see a student come here and be like, oh, maybe x equals 10 or x minus 3 equals 10. We cannot do that. It has to be a 0 on the right side for you to split things up like this. Yeah, so is that the answer? It's not the answer. At least not completely. What's the issue? Yeah?
Isn't it 5 because you can't have negative log?
Right. This guy we need to reject. because you can't have the log of a negative number. We covered that last time as well. Notice here, if I plugged in x equals minus 2 into this guy, I would have log of minus 5. That's nonsense, right? So minus 2 is actually not a solution. X equals 5 would be the answer. Another thing, every time you have an answer, you should make sure it actually makes sense, intuitive. Oftentimes, whenever you get an answer, you have several answers. You want to make sure, do these all apply? Do they all work? Really be careful. So, are there any questions? So I just want to make sure we know all that and we've learned all those lessons, and you guys seem okay for now, but we'll see with that quiz on Tuesday. It's only a few people that know everything, or everyone is kind of on top of it. So we'll end right there. Enjoy your weekend. And next week we'll start topics. We'll start limits on Tuesday after the quiz.